In this section, we're going to cover the Frayer's diagram I made for the law of refraction. We first look at the definition. As light ray travels from one media to the other, the ratio of the incident angle to the refracted angle extended from the normal of the surface is inversely proportional to the inverse sign of index of refraction the light travels in the incident media to the refracted media. That means that the angle is inversely proportional to the sine inverse of the refracted media over the incident media. And this is essentially what Snell's law tells us. I express in this way, so I think it is more clear to say where does the angle comes from and how does the light ray changes when it goes from one media to the other. So essentially, when we're looking at the law of refraction, we're looking at this equation, which tells us how a media changes the relative speed of light. Because light travels in vacuum with the highest speed of 3 times 10 to the 8 meters per second. When it travels in media, in some medium, it changes the relative speed. So the speed in the medium would be lower. And by the Snell's law, we could relate the angles it refracted with the index of the refraction. And when we look at the applicability or the limitations, it only apply when the light travels from one media to the other. So when we're looking at the same medium, let's say water, then the light will not refract because there's no a boundary that differ in medium. And this is some related helpful diagrams which I draw that correlates how light travels from a medium with lower index of refraction to a medium with a higher index of refraction. So when it travels from a lower index of refraction to a higher index of refraction, we're looking at this diagram, and the light bends closer to, it should be normal. It shouldn't be boundary. It bends closer to normal. I made a mistake. It should be closer to normal. And this is away from normal. So when we're looking at the light ray travel from with a medium with less index of refraction, then it bends closer to the normal. But when we're looking at the light rays travel from a higher index of refraction, then the light ray would bend away from the normal. So this concludes the whole Frayer's diagram for the law of refraction.